Behind ordinary-looking walls are hundreds of tightly packed straw bales. After over 2 years of construction and countless trials, the project is finally complete. So, how is a straw bale house built? And how can such a simple material make a home both durable and energy efficient? Instead of a conventional concrete foundation, this house uses a rubble trench foundation, a drainage trench filled with compacted stone beneath a reinforced concrete grade beam. This system keeps the foundation strong and well drained. Construction began with rigid perimeter insulation and geotextile fabric to protect the drainage system from soil. The trench was filled with compacted stone, then topped with a reinforced concrete beam. This design keeps the foundation dry while using far less concrete. With the foundation in place, the base was graded and leveled to set the final floor height. A moisture barrier, rigid insulation, and reinforcing steel mesh were then installed across the slab. At this stage, the house layout began to take shape, with the garage and living area clearly defined. Since the garage didn't need radiant heating, its concrete slab was poured first. The living area was poured after the PEX heating system was fully installed beneath the floor. The project then moved to structural framing. But unlike a typical house, the timber frame only needed to support the building's loads. Since the walls would be made from straw bales, the frame was kept simple, with open sections left for them. The structural frame took shape as the load-bearing posts and main beam were installed. The largest beam was made by laminating two LVL beams into one nearly 24 centimeters thick and 14 meters long, providing primary support for the loft. The roof was also built in stages, starting with the garage roof, which set the main structure's final height and the upper window's positions. These clear-story windows are high-level openings designed to draw natural light deep into the home. With the house facing south, they capture sunlight throughout the day, keeping the interior bright while reducing the need for artificial lighting. With the roof height set, the remaining trusses and OSB sheathing were installed, completing the upper floor and roof structure. The interior layout began to take shape, with 3 bedrooms and a shared bathroom upstairs. Clear-story windows above bring natural light deep into the home while maintaining privacy below. A waterproof membrane was installed before the metal roof. The house uses a 24-gauge standing seam steel roof with interlocking raised seams instead of exposed screws. This design reduces leak risks and allows the panels to expand and contract naturally with temperature changes. Just 2 days later, the main roof was complete, ready for the first straw bale walls. At last, the straw bales began going into place. Rather than simply filling the gaps, they serve as the home's primary insulation. Before installation, the base was prepared with packed, crushed stone and long stakes to hold the bales firmly in place. Each bale was then trimmed and reshaped to fit tightly around the structural frame, as almost none could be used without modification. Every 3 courses, the straw was compressed with a squash block to reduce settling and create a denser, more stable wall before adding the next layers. Both sides of the wall are compressed with a specialized tool, then trimmed and shaped. Excess straw is removed to create a flat surface for an even plaster bond. Electrical installation followed, requiring careful planning in the straw bale walls. Since another 3 centimeters of plaster would be added, every outlet and switch box had to be recessed to the correct depth. As winter approached, doors and windows were installed to enclose the house before the cold arrived. The house could now retain heat efficiently, allowing interior work to continue. Combined with insulated straw bale walls and radiant floor heating, the design keeps energy use low year-round. Winter arrived before plastering could begin, as lime plaster needs several days of warm weather to cure. The straw walls were covered with moisture-resistant paper and welded wire mesh, tied through the bales to form a reinforced base for plaster. Finally, the house was wrapped in house wrap to protect the walls from rain, snow, and wind. Next came roof insulation. Baffles were installed along the eaves to create a continuous ventilation channel, improving airflow and reducing moisture buildup. Part of the roof was insulated with rock wool, while the rest used natural sheep's wool. Besides excellent insulation, sheep's wool regulates moisture naturally, allowing the roof to breathe without a vapor barrier. The house was ready for natural lime plaster. Before plastering, the inner wire mesh was installed and tied to the outer layer through wires running across the walls, creating continuous reinforcement. Extra reinforcing mesh was added around windows, doors, outlets, and switches areas prone to cracking from shrinkage and temperature changes. This reinforcement improves the plaster's long-term durability. The plaster was made from natural hydraulic lime, coarse and fine sand, plus a small amount of chopped straw for better bonding. The garage was used as a test area to refine the mix and application before plastering the rest of the house. After the successful garage test, plastering continued throughout the house. Transitions between the straw bale walls and drywall were finished, while ceilings and recessed lighting were prepared before the final plaster coat. Experience from the first sections improved consistency. The plaster mix and techniques for tricky areas, such as above windows, were refined. After the first coat, the surface was scratched to create a rough texture for the next layer. Nearly 2 weeks later, once the first coat had fully cured, the second layer was applied to smooth and level the walls, correcting any remaining imperfections before the final finish. While the plaster cured, work inside continued, with the drywall ceilings gradually completing the interior. Nearly 2 weeks later, the straw bale walls received their final coat, a pre-mixed natural lime plaster that delivered a smoother, more consistent finish and color. After a thin coat was applied, the surface was floated smooth, bringing fine sand to the surface and creating the natural texture of lime plaster. This became the final interior finish, keeping the lime's soft off-white color without any paint. The in-wall plumbing was completed, with water, drainage, and vent pipes installed throughout the kitchen, bathrooms, and laundry. Vent stacks extended through the roof, while the main wooden staircase and remaining drywall work brought the interior close to its final form. Work then moved outside, where the straw bale walls received 3 coats of natural lime plaster. Outdoor conditions made the job more challenging, but despite falling temperatures and persistent rain, the crew kept working to stay on schedule. After several plaster coats, the exterior received its final layer, a pre-mixed natural lime plaster with mineral pigments that gave the house its finished color. After hundreds of hours of preparation and plastering, the straw bale walls were finally complete, inside and out. Inside, the drywall joints received 3 coats of compound, each sanded smooth for a flat, even finish. The walls and ceilings were primed with an airless sprayer before receiving a knockdown texture finish. A second primer coat sealed the texture before painting. Neutral tones were used in the living spaces, while each family member chose an accent color for their bedroom. The living room ceiling was finished with tongue and groove wood, treated with the traditional Japanese shosugi-ban technique. Each board was charred and wire brushed to resist moisture, insects, and rot. Since the walls were slightly curved, every board was custom cut, giving the interior a distinctive handcrafted character. The floors were finished with rammed earth made from clay, sand, chopped straw, and water over the concrete slab. After the base dried, a finer coat was added and burnished for a denser, smoother surface. Finally, several coats of natural linseed oil were applied to improve durability, reduce water absorption, and preserve the floor's earthy appearance. The loft railing was built mostly from reclaimed materials, using rust-cleaned 25mm reinforcing steel bars threaded through wooden posts. The result is a simple, sturdy design that complements the home's handcrafted, natural aesthetic. The loft floor was covered with an underlayment for sound reduction and stability, followed by click-lock cork flooring. It was chosen for its thermal insulation, sound dampening qualities, and comfortable feel underfoot. The final interior features, including kitchen cabinets, wooden doors, and built-in storage, completed the home. From the foundation and timber frame to the straw bale walls and interior details, nearly everything was built by the family. After more than 2 years of work, ordinary materials were transformed into a modern, energy-efficient home built to last for decades.